Hello and welcome everyone. This is Mohammad Izamam from Sai Meda ESET Coaching Center, Koti, Hyderabad. Sai Meda Koti, Hyderabad is providing a golden opportunity to all the ESET 2024 and as well as ESET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Sai Meda Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే సాయి మీద కోటి హైదరాబాద్ లో ఎవ్రీ సింగిల్ ఇయర్ వీ హ్యావ్ ప్రూవన్ దట్ మాక్సిమం ర్యాంక్స్ ఇన్ ఆల్ ద బ్రాంచెస్ ఈసీ ట్రిపుల్ మెకానికల్ సివిల్ అండ్ కంప్యూటర్ సైన్స్ లో టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్ తో పాటు మాక్సిమం ర్యాంక్స్ ఇన్ టాప్ 10 అండ్ టాప్ 50 లో కూడా మాక్సిమం ర్యాంక్స్ ఆర్ దేర్. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches, subject wise and as well as topic wise. Previous ESET examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo. Kani Sai Meda Koti Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ESET examination questions with which you can understand the level of teaching, the expertise which is there in the Sai Meda Koti Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ESET 2024 and ESET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Hello everyone, this is Mohammad Inatullah from the Sai Meda Coaching Center, Koti, Hyderabad. So in this video, we are going to discuss the previous ESET questions of the topic shear force and bending moment. Okay, so this is the second chapter we have taken over here. So shear force and bending moment, whatever the questions has been asked till now in the ESET examinations, we have to cover all these questions over here. Okay, now let us see the first question now. A simply supported beam of length L is subjected to a point load at mid span. The shape of bending moment will be. Okay, now let us see this part. What we are having first over here, a simply supported beam. If you are taking simply supported beam over here, let us take this part. This is simply supported beam we have taken. This is simply supported beam. What is the meaning of simply supported beam actually? Whenever the beam, it is having the two supports at its ends. Okay, so we are calling it as what? A simply supported beam. So a simply supported beam of length L. So this complete length whatever we are having, this complete length we have taken it as what? L is subjected to a point load at a mid span. So at the midpoint over here we are having the point load. So this, let us take it as a point load over here and let us mention this part as W. At the mid span we have taken, mid span means this length we are taking it as L by 2 we have taken, and again this length we have taken it as L by 2. Okay, this part we have taken L by 2 we have taken. Now let us see the next point. The shape of bending moment will be. Okay, the shape of bending moment. So for these questions, these are the standard questions actually. So compulsory what you have to do means, I'll explain you how we are getting that shape actually, but after that you have to remember directly what are the shapes we are getting for this part. Okay, so for standard conditions, if you take cantilever beam with point load, if you take cantilever beam with UDL, if you take cantilever beam with UVL, but maximum questions will be from point load and UDL itself. Similarly, simply supported beam we are having whenever we are having the point load at the mid span. Then similarly, simply supported beam with UDL. So these are the standard questions we are having. Directly we have to remember the diagrams how we are getting over here. Okay, now let us see this part. So this point load at the midpoint we have taken it as W, and let us take this part as RA we have taken, and this is RB. Okay, so we are having the reactions over here. Whenever we are having the supports, that we are calling it as what? A reaction, RA, RB. Now first let us find out what is RA value and RB value, then we have to go for shear force and bending moment. So first what we are taking over here, our first step is, now whatever the forces we are having over here, algebraic sum of all the forces equals to 0. So we are taking this part. So upward forces equals to downward forces. Upward forces equals to downward forces. So what we are having, RA, RB we can take over here, and W we can take. So first condition we are taking it as RA plus RB, it is equals to W. Okay, this is the first equation we are making over here. RA plus RB is equal to W. Now next point what we are taking means we are taking moments. We are taking moments at point A. So whenever we are taking moments at a point A over here, moment means what? Force means load, whatever we are having, force or load, and we have to take perpendicular distance. Okay, like that we have to calculate over here. So whenever we are taking over here, now for this point also, at a point A, if you have taken this point, now we have to take clockwise moments and anti-clockwise moments. Okay, so what is clockwise and what is anti-clockwise moments over here? So if you are taking this point over here and we are taking this load, this reaction we have taken, so it is looking like what? It is looking like what? Clockwise or anti-clockwise. So this is becoming what? Clockwise, and this part it is becoming what? Clockwise. Okay, this is anti-clockwise, this is anti-clockwise, and this is what? Clockwise. So now what we can take means, let us take this part as clockwise moments, it is equals to anti-clockwise moments. So we are taking this part as RB. First we have taken RB into, this is the force, load we have taken. What is the perpendicular distance we are having up to point A? Up to point A means what is the distance we are having? L. So RB into L, which is equals to, okay. Now next we have to take this part, clockwise we have to take over here. So W we are having, and what is the distance we are having over here up to point A means L by 2. So let us take this part as W into L by 2, okay. This part we have taken. Now what will happen? This L gets cancelled. What is the RB value we are getting over here? RB is equals to W by 2. Okay, so RB value is equals to W by 2. Now with the help of this RB value we can find out the RA value also. So if you are substituting in this, therefore RA value, RA, it is already W we are having over here, W plus RB if you are sending over there means what? Minus RB. So minus RB means what we are having? W by 2, which is equals to W minus W by 2 means again what we are having? RA, it is equals to W by 2. Okay. So directly we can go with this part. RA value is W by 2, RB value is W by 2. So but this is the actual procedure. Now we are having one shortcut also for this part. What is the shortcut we are having means, whenever we are having the symmetrical loading, means the load, this point load, it is acting at the middle of that part, mid span. So whenever it is acting at mid span, so what we can do means directly we can take this part. RA, it is equals to, what is the load we are having over here? Load is equal to W. So W by 2 and RB it is equals to W by 2. Directly we can write over there. No need to go for all these calculations. Whenever we are having this point load, and whatever the value will be then, that value we have to do divided by 2, will be getting RA value and RB value. Okay. So this part is completed. Now after this, what we have to do? We have to find out shear force and bending moment values. What we have to calculate? Shear force values and bending moment values. So first let us go for shear force over here. So first let us go for shear force. Now shear force means how many points we are having over here? A point, B, and let us take this part as C. Okay, A, B, C, 3 points we are having. So first let us go with the shear force at a point B. Okay, shear force at point B. Now for shear force and bending moment, actually we are having some sign conventions. What we are having? Sign conventions. So what is happening means, listen here carefully. So whenever we are having this part, okay, this is a beam we have taken, and we are having this load we are having. Okay, this load we have taken. So what we have to do means, whenever we are considering that load, suppose if you want to find out the shear force at this load means, what we have to do? We have to draw the imaginary line after this. What we are drawing? We are drawing the imaginary line. So if you are drawing this imaginary line, and we have to check, now this load, it is lying under which quadrant? Which quadrant means what? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it is lying under which quadrant we have to find out. So after finding that, if that point load or whatever the load we are having, if it is lying under quadrant 1 and quadrant 3, then we have to take it as what? A positive. What we have to take? A positive. Now similarly, if it is lying under quadrant 2 and quadrant 4, then we have to take it as what? A negative. Quadrant 1, quadrant 3 we have taken positive, quadrant 2 and quadrant 4 we have taken it as what? A negative. So this is a sign convention. This is a sign convention for shear force. Similarly, we are having sign convention for bending moment also. What we are having? Bending moment also. Okay, now listen here carefully. So what we have to do now? Suppose this is a beam we are having, and if the loads are acting in this direction, in the upward direction. So whenever we are having the loads in the upward direction over here, so what will happen? It will be looking like this part. Okay, it will be looking like this part. So if you want to remember over here, okay, if you want to remember over here, what we are taking means we are remembering this part as a smiley face. Okay, it is looking like what? A smiley. Okay, smiley face. So whenever we are having this part, we have to consider this part as what? A positive. What we are considering? Positive. And this we are calling it as a sagging. What we have to call? Sagging. Now next, now whenever we are having the load as in downward direction, whenever we are having in downward direction, now it will be looking like somewhat sad face over here. So now what we have to do, whenever we are having the sad face, then we have to remember it as what? A negative. Okay, so this is positive and this one is negative, we have taken over here, sagging and a hogging. So these are the sign conventions we are having over here. By using the sign conventions, let us apply this part, what we are having. So shear force. Now if you are considering this load means, if you are drawing the imaginary line over here, if you are drawing the imaginary line, so this load, it is coming under which quadrant? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. It is lying under quadrant 4 over here. Quadrant 4 means what we have to take? Minus. So we have taken minus. And what is this load value we are having? This load reaction means W by 2. So let us take this part as W by 2. Okay, so shear force at point B we have taken it as minus W by 2. Now similarly shear force at point C we have taken. So shear force at point C we are taking means, now what we have to consider, first we have taken this part now, so directly we are writing over here minus W by 2 we have taken. Now we have to take this load also. If you are taking this load, now we have taken the imaginary line over here. So this load, it is coming under quadrant 1. If it is coming under quadrant 1 means we have to take positive. So positive, what is the value we are having? W. So which is equals to plus W minus W by 2, it is equals to W by 2. Okay. Now shear force at point B, shear force at point C we have calculated. Now we have to calculate a shear force at point A. No need to calculate shear force at point A for a simply supported beam. Listen to this point very carefully. Shear force at point A, it is equal to RA value. Whenever we are discussing the simply supported beam problem, so directly what we have to remember over here, shear force at point A is equals to RA. What is RA value we are having over here? W by 2. Okay, so the shear force values we have completed. Now let us go with the bending moment values. Now we are trying to calculate a bending moment. Okay, bending moment values. Now in this bending moment values, first let us go with a bending moment at a point B. Okay, at a point B. Now whenever we are taking this bending moment, this point we have taken, what is the moment formula we are taking over here? Force into perpendicular distance. Load we are taking. Okay, load is equals to what? W by 2 we have taken. But what is the perpendicular distance we are having? For this point only, for this point we are not having any perpendicular distance. So distance will be what? 0. And if you are taking this part means it is looking like what? It is looking like what? This part, no? Smiley face we are having over here. So we have to take it as a positive. So if you are taking positive, that part, positive we have taken, and we have taken W by 2 into 0, which is equals to what? 0. Bending moment at point B is equal to 0 we have taken. Now next, bending moment at a point C, it is equals to. Now for bending moment at point C, what we are doing is, again we are taking this part over here. So this part, it is becoming what? We have taken plus W by 2 because it is becoming smiley face into, this is a load, and what is the perpendicular distance up to point C? Then again don't do mistake over here, we are now taking all the length, we are taking up to point C only. Up to point C, what is the distance we are having? L by 2. So let us take this part as L by 2. Okay, this part we have taken W by 2 into L by 2. Now next, if you are taking this part, now it is becoming a sad face, so we are taking it as minus, and W we have taken. Now we are not having any distance means 0. For this point, for this load, at this point only we are not having any distance, means we have taken 0 over here. So it is equals to, so this part will become 0 and this part, it is becoming WL by 4. Okay, WL by 4. Now next, last bending moment value we are having over here, bending moment at a point A. Now bending moment at point A, what we are having, up to this point we have to calculate. Up to this point means, now what we are taking over here, again we are taking plus over here, plus W by 2. W by 2 into, and up to point A, what is the length we are having over here? L. Okay, so this part we have taken it as L. Okay, now next, for this load, as it is in downward sad phase, so we are taking this part as minus we have taken, then load is W we have taken, and what is the length we are having up to point A? Up to point A means L by 2, so we have taken L by 2. For this load we are not having any perpendicular distance. If you are not having any perpendicular distance for this part, so it will become what? 0. So it is equals to WL by 2 minus WL by 2 means what? 0. Okay. So we have to remember one most important points in the case of simply supported beam. One of the important point is shear force at a point A. Shear force at point A is equals to what? RA, and bending moment at two end supports. Bending moment at two end supports, whatever the supports we are having over here, bending moment at point B and bending moment at point A will be always 0. Okay, so no need to calculate over there, directly we can remember the answer as what? 0. Okay, so this was all about RA value, RB value, then shear force values, bending moment values, all we have calculated. Now let us try to draw the diagram over here. Okay, for drawing the diagram, again what we are having is, listen carefully. We have to remember some points over here, what we are having. So first we are taking over here type of loading. We are taking type of loading over here. Next for shear force, and next for bending moment. Okay, we are taking this one. This is most important for drawing the diagrams or for remembering the diagrams what we are having. First let us take it as a point load. Okay, point load or concentrated load. Point load or concentrated load. So whenever we are having point load or concentrated load, for shear force we have to draw the vertical line. Okay, this part we are calling it as a sudden change. What we are calling over here? Sudden change. Vertical line we have to draw. For bending moment we have to take point itself. Okay, so whenever we are having the point load means we have to take a vertical line for shear force, and for bending moment we have to take the point. Okay, now similarly, if you are having no load condition in some region, if you are not having any load, then what we have to do? For shear force we have to take horizontal line, and for bending moment we have to take a inclined line. Okay, like this we have taken. Now next, let us go for now we are going for UDL. Okay, if you are going for UDL, uniformly distributed load, if you are going for UDL means now what we are doing? For shear force we have to take inclined line, and for bending moment we have to take a parabolic. Okay, what we are taking over here? Parabolic. Okay, it will be shape on the parabola. Now we are taking it as UVL. Now whenever we are taking UVL, uniformly varying load, if you are taking uniformly varying load, for shear force we have to take the parabolic part over here. Okay, what we are taking? We are taking a parabolic part, but for bending moment we have to take cubical. Okay, we have to take cubical. So it is similar to parabolic only, but we are having some larger curve part over here, this smaller curve we are having. Okay, so like this we are taking this part as what? A cubical. This part we have taken. Now next, after UVL, if you are taking a moment, concentrated moment, if you are taking moment over here, now what we are doing means we are taking the point for shear force, we are taking point for, and for bending moment we are taking the vertical line. Okay, for bending moment what we have taken? Vertical line. So these are most important conditions we are having for diagrams. We have to remember this part compulsory. So point load means what we have taken over here? Vertical line. Bending moment point, no load horizontal line, inclined line, UDL inclined line, parabolic, then UVL parabolic, cubical we have taken, moment means point, and vertical we have taken. Okay. Now by using these conditions, let us try to draw the diagram of the shear force and bending moment. Okay. Now let us see this part over here. Now first let us try to draw the shear force diagram. Okay. So now whenever we are drawing the shear force diagram over here, shear force diagram. Okay, first we are drawing the shear force diagram over here. Now RB value, what is shear force at B we are getting over here? Shear force at B is minus W by 2. Minus W by 2 means in the negative part we are taking over here and for point load what we have to take a vertical line. Okay, so minus W by 2 means vertical line we have taken like this. Now we are not having any load between this. Okay, we are not having any load between this. Just wait a minute. So let us take the line over here. We are taking the line as this part. Now let us draw the shear force diagram. For the shear force diagram we have taken this part. Okay, now what is shear force at point B? We are having minus W by 2, minus W by 2, and for point load we are having vertical line, so we have taken this part as vertical line we have taken, and this is what minus W by 2. Okay, and we are not having any load between this. If you are not having any load, for shear force what we have to take a horizontal, what we have to take a horizontal line. Okay, up to this we have taken horizontal line over here. Next part what we are doing, shear force at point C. If you are taking shear force at point C, what is the value we are getting? W by 2. If you are getting W by 2 means, now let us take this one. So we are getting the final answer as W by 2. W by 2 means what? A positive. So let us take it as positive. Again we are having point load means we have to take vertical line over here. So for this vertical line, now we have taken it as W by 2. Then again we are not having any load. If you are not having no load means, if you are having no load means what we have to take a horizontal line. Okay, after taking horizontal line, then we are taking this part. Okay, so this is becoming plus W by 2, and this is positive part we are getting, this is a negative part we are getting. Okay, so this part we have taken. So this was shear force diagram. What we have done over here, shear force diagram is completed. Now let us draw bending moment diagram, what we are getting over here. So if you are going with bending moment diagram, let us take this one, bending moment diagram. So bending moment at point B, 0. Bending moment at point B, what? 0. Bending moment at point A, 0. And for point loads also what we have to take? We have to take point only for bending moment. Now bending moment at point C. Bending moment at point C, what we are getting? WL by 4. So at this point we are getting WL by 4. This is WL by 4 we have taken. Okay. So if this is WL by 4, this part we have taken it as WL by 4. Now we are not having any load over here. If you are not having any load, for no load conditions what we have taken? No load conditions for bending moment we have taken inclined line. Similarly, let us take this part. So over here we are taking inclined line we have taken, and over here also we have taken what? A inclined line. Okay, so this is what? A bending moment diagram. This is what? Bending moment diagram. So this was a standard question, that's why I have explained you complete part over here. Now from this question only again and again the questions will be repeating, so directly we can give the answers over here. Okay, now first let us check the first question what we are having. A simply supported beam of length L is subjected to a point load at mid span. The shape of the bending moment will be, the shape of the bending moment, it is looking like what? It is looking like rectangle, trapezium, triangle or parabola. So only we have to remember the shape of that bending moment what we are getting. So it is looking like what? A triangle. Okay, it is looking like what? A triangle. So no need to solve all this question. Only whenever we are remembering this part, how is the diagrams we are getting, where we are getting the bending moment, or what is the bending moment at point B, what is the bending moment at point A, what is the maximum bending moment we are getting, what is the shear force at point A, what is the shear force at point B. Directly if we are remembering the answers, directly we can write the answers in the examination also. Okay, so no need to discuss all this concept. For first question I have explained you this much. Whenever we are getting the similar questions, directly we will give the answers for that questions. Okay, so option 3 is correct. Now let us go with the next question over here. What is the next question we are having? A continuous beam is one which is fixed at both sides, fixed at one end, free at the other end, extending beyond the supports, supported on more than 2 supports. Okay, now we are having continuous beam. For continuous beam, let us discuss some of the different types of beams we are having. First, if you are seeing cantilever beam over here, okay, what we are taking over here, first is cantilever beam. If you are going with cantilever beam, what is the meaning of this part? So we are having one end is fixed and the other end will be what? Free. So whenever we are having one end is fixed, another end is free, that beam we are calling it as what? A beam. Now next we are going with simply supported. We are taking this part as a simply supported beam. If you are having simply supported beam means, now what is the meaning of this part? Suppose we have taken this beam. Now in this beam we are having two ends. For this two ends we are having one support over here and the another support at the other end. Okay, so whenever we are having these supports at the ends, whenever we are having the supports at the ends, then we are calling it as what? Simply supported. Okay, so this is one type of beam we have taken. Now next we are taking it as, third we are taking it as, suppose we are taking over here as fixed beam. Taking fixed beam. If you are taking fixed beam means the beam is fixed at both ends. What? The beam will be fixed at both the ends. Now if you are taking over here propped cantilever, now what we are taking? We are taking it as a propped cantilever. If you are taking propped cantilever means it is similar to cantilever only. Similar to cantilever means it is fixed at one end, and over here we are having free end now, but in this free end will be supported. Free end will be what? Supported. So whenever one end is fixed and the other end is supported, then we are calling it as what? Propped cantilever. Now next, similarly we are having overhanging beams. Now first we can take it as a single overhanging beam. So if you are going for single overhanging beam means what we are taking over here. This is a beam we have taken, and one support is at end only, at end point only we are having one support, but another support we are having apart from the end, means at some distance from the end. So that part we are calling it as what? Single overhanging. Okay, so we have taken this part. Now next we are having it as double overhanging. Double overhanging. Now what is the meaning of double overhanging over here? Double overhanging means we are having the supports, but that supports will be not at the end points. We are having the supports apart from the end points, means at some distance from the end points. Means one support we are taking over here, this is one support and this is another support we have taken. It is not at the end points, it is at a certain distance from the end points, that we are calling it as what? Double overhanging. Single means only one support is away from the end point. Double means what? Two supports are away from the end points, we are calling it as what? Double overhanging. Now next we are having it as a continuous beam. Now what is the meaning of continuous beam we are having? Continuous beam means whenever a beam it is having more than two supports. If it is having more than two supports, then we are calling it as what? A continuous beam. Okay, so let us check the options what we are having over here. Continuous beam is one which is fixed at both the sides, fixed at one end, free at other end, extending beyond the supports, or supported on more than two supports. So continuous beam means supported on more than two supports, means the fourth option. Fourth option is correct.
So my dear students, for ECET 2024 and ECET 2025, Sai Medha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Sai Medha Koti Hyderabad in this very week, guys. In this very week only we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద సాయి మీద కోటి హైదరాబాద్ as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.